Hi everyone, it's good to be here. I'm just going to share my slides. I hope you can see those. Good, okay, here we go. So this is the third and last of the three big challenges today. So I'd better wake you up, I think, seeing as we're getting to the end of the 2-hour session. Bit of housekeeping first. When I say Devon, I mean Devon, Plymouth and Torbay. When I say carbon, I really mean greenhouse emissions in their totality, of which the carbon in carbon dioxide and the carbon in methane are the two biggest sources. And when I say retrofit, I mean doing things to existing buildings in Devon to make them zero carbon. Next slide. So this is important because 40% of the total carbon emissions in Devon come from buildings. So on that pie chart, that's all the emissions in Devon. We've heard about road transportation from Nick. We've heard about that agriculture and land use emissions have been dealt with elsewhere. But on the top right-hand corner is residential buildings. 20% of our emissions come from homes, and another 20% come from other public and business buildings as well. So this is a big issue. You put those two things together, buildings are the biggest source of carbon emissions. And those carbon emissions come from, in the main, they come from the energy used from heating and hot water in those buildings. That's what causes the most emissions. But then also emissions come from electricity that's used for our appliances, for everything we plug into plugs, and our lighting as well. But it's heating and hot water that are the really big sources of carbon emissions from buildings. And if you look on that pie chart at the bottom there, it's mains gas, which is the biggest fuel that's used for heating and hot water in Devon. And also oil and LPG, liquid petroleum gas. These are all fossil fuels. So burning them to heat our homes creates a lot of carbon dioxide, which causes a big proportion of our total carbon emissions in the county. So what needs to happen? Well, we need to insulate all our buildings so that we use a lot less energy for heating. That's the first thing we need to do. And that's actually the most cost effective to do, to stop using energy to waste in heat that leaks out of houses too quickly. That's the first thing to do, insulate. The second thing we need to do is stop using mains gas and also oil and LPG, all the fossil fuels. We need to stop using it altogether. And we need to replace that source of fuel for heating. We need to use electricity for heating and hot water, and still use electricity for everything else, you know, for the appliances, for plug power, and for lighting as well. But we need to electrify our buildings for everything. And the fourth thing here is we need to ventilate homes. If you wrap them up and insulate them, you need to still ventilate them so that fresh air comes in and air gets changed, but in a sustainable way. Because we need to do that because buildings need to be healthy, and the air quality in homes is really important to ensure that we're all healthy, either in our homes or in workplaces or schools or wherever. So if we're going to wrap them up and insulate them, we need to ventilate them as well. Now, I've just put a little line in here about hydrogen. Hydrogen's been mentioned elsewhere as a possible transport fuel, and Kerry mentioned hydrogen as well. And you will hear some people out there saying that, oh, we don't need to do anything really with buildings because we're just going to take out mains gas and we're just going to put hydrogen through the grid. And instead of having a gas boiler, we'll have a hydrogen boiler and everything will be the same. Well, that isn't going to happen. There isn't enough hydrogen that we can make from renewable electricity to go around for all its needs. And that hydrogen is going to have more value being used in heavy lorries and in heavy industry where they need to use a lot of gas or a lot of heat rather. It's not actually going to go down the pipes and get into homes or other buildings, and particularly not in Devon. It may do in some places in the country, small places where you've got a lot of industry and you might have a hydrogen network there for industry purposes. Maybe some buildings will be connected to that as well. But I really don't think that hydrogen is going to be powering all our homes. I just don't think that is going to happen. So we need to think really about electrification of heat and hot water and insulating buildings. That's what really needs to happen. Let's come on to the challenges, because that all sounds quite easy, doesn't it? Well, unfortunately, it isn't easy. Retrofitting buildings is a real challenge. It's not only the biggest source of carbon emissions, it's the most difficult thing to decarbonise. So the first challenge, electrifying our homes, the first challenge with this is that electricity is 4 times more expensive than gas. So just turning off the gas network and using electricity to heat and hot water everything is going to put bills up a lot, and that is not sustainable. It's also not sustainable for the electricity grid. We just wouldn't be able to produce enough electricity if we did nothing else but just switch out gas for electricity. It's not possible. So what we need to do is insulate so we don't need as much electricity, and use heat pumps, which are electrical heating, which is more efficient than normal heating. So in normal electric heating is like a electric bar fire or a panel radiator or a night storage heater, and you put 1 unit of electricity in and you get 1 unit of heat out. But a heat pump is different. And that little picture, which I borrowed from a Devon company called New Heat, that's an air source heat pump that sits outside somebody's home. Heat pumps are magic, really, because you put 1 unit of electricity in and you get 3 units of heat out. So it costs 1/3 less to heat and hot water from a heat pump than it does from normal electric heating. So that helps to address the issue of electricity being more expensive than gas. Insulate first, use less, and then what you do need, use a heat pump. However, and there is a but here, first of all, the insulation of the home needs to be very effective to make a heat pump work comfortably and affordably for everybody. Secondly, we need the electricity grid to become zero carbon. And we're taking that as a given. It's on the journey, as Kerry has set out. The journey towards a zero carbon electricity grid is well underway. It's well underway. And in the next decade or so, we will be not using any fossil fuel to make electricity, to go into the electricity grid. So that one we can say is taken care of, or will be taken care of, if we're allowed to put enough wind turbines where they need to be, for example. And the third thing is that we need to generate more electricity. Kerry said we need at least 2 times the amount of electricity that we're generating at the moment, and it all needs to be for zero carbon renewable sources. And we also need enough electricity at the right time, because our heating is seasonal. We use a lot more in the winter than we do in the summer. So we need more electricity, and we need even more of it at the right time at particular times as well. But the big challenge here that we need to think about is we need to insulate the homes and convert heating to heat pumps in the majority of houses. Another challenge to think about is scale. There are a lot of buildings in Devon. So the homes we all live in Devon, there's 540,000 of them in Devon. And I've just put a note there to say that 10.6% of those homes we class as being in fuel poverty. And this is a factor of 2 things. 1, the energy efficiency of the houses as they are at the moment, and 2, the household income. So if you're in a low income household and your home is not very energy efficient and it costs a lot to heat, then the chances are that you're in that 10.6% of households that are in fuel poverty. So we have to understand about, when we're thinking about retrofit, we have to think about affordability for everybody. That's really important. So as well as homes, there's another 56,000 public and business buildings. That's offices, it's it's schools, it's public buildings, it's libraries, it's all those buildings that aren't homes, basically, that are heated and powered. So just to think about the scale of the challenge, we need to retrofit about 600 buildings a week for 20 years if we're to get zero carbon buildings by, say, 2041. That's a lot. We're not doing anything near that at the moment, and we never have done that volume and scale. So a big question is, how do we speed up delivery? How do we make this so we're doing a lot of it quickly, and not just for a few weeks or a few years, but for a few decades, actually, to get the job done? Another challenge to think of is the retrofit that we've done so far. So what we've largely been doing to our buildings, to our homes and offices, is that we've been doing the more simple, easy measures. Things like cavity wall and loft insulation, double glazing, some PV on roofs, photovoltaic, making electricity put on roofs of some buildings. We've been doing those, and they're quite easy. They're good, they do reduce emissions, but on their own, they don't get us to net zero. They get us some of the way. So if you were to take a house and do cavity wall insulation and loft insulation and make sure the windows were double glazed, you might reduce its carbon emissions by, say, 30%, but it's not 100%. We need to do a lot more than that. Second thing to say about retrofits so far is it's largely been driven by government grants. The government have paid for a large share of it. And those grants have been very stop-start. They've been turned on for a year or two, and then they've been turned off again. And then they get turned on again for something else. And I think what that's created in people's minds is confusion about what retrofit is about and what measures are good, and can I get a grant? You used to be able to, why can't I now? And actually, when you think of the scale of retrofit that needs to be done, those numbers of buildings that need to be retrofitted, the government, and then that's ultimately the taxpayer, probably can't afford to pay for it all. We need a different way of doing that. And the third thing about retrofits so far is that really the easy things, those cavity wall and loft insulations, they've mostly been done. Most homes have got those if they're eligible to have them. They've mostly been done, so there's not much left of the easy stuff to do. And then the last two here are questions really about, first of all, the quality and the performance of the retrofit so far. Does the retrofit measure, once it's installed, does it actually deliver the energy bill savings and the carbon savings that it's meant to? Well, actually, we don't measure that mostly, but where we do, we often find that it's not as good as it should be. And the quality of the installation by the company that's done it hasn't quite been good enough in some cases. And then the final point there is, do people really want this? Do people really want this to be done to their homes? Some people do, but does everybody? Does this have mass market appeal? And I don't think it does really. And I think one indicator of that is that if you look on the TV, almost every night, there's something about home makeovers, isn't there? Making your home bigger, better, nicer, more modern, perhaps, those sort of home makeover programs, or garden makeover or whatever. But I don't think there's a single program on the telly, not that I watch anyway, which is about carbon reduction in your home or energy efficiency in your home. It doesn't really have the mass market appeal that it needs to get every house done. So that's retrofit to date, the way that we've done it so far to date, which it frankly hasn't been good enough to get buildings to zero carbon. And I just put this point in here as well. Retrofit isn't all about zero carbon and carbon emissions reduction. It's also about fitting into the future well as well. Nick has talked about we need to electrify vehicles, so we need electricity to do that. And Kerry's talked about the challenges about making enough electricity from renewable sources. Electrifying our homes and retrofitting them makes our housing stock fit into that energy system of the world and in the future, and operate in a grid-friendly way. But in addition to that sort of energy system benefit, it's about making homes affordable to live in and heat, making them warm every day, and making them healthy places to be. No more mold and damp, no more cold rooms. Every building, a healthy building to live in, to work in, to learn in. That's what we need to be aiming for as a society, I would say, and Retrofit can deliver this. It's also about local jobs and businesses. All these local buildings, they're going to need local work to be done to them. So there's a local economic benefit from doing this. And also there's this issue about making places look and feel better. You know, some of our built environment areas, you know, some of our towns and cities, they don't look too great. They look a bit tired. And wrapping them up in a way that makes them look good delivers benefits in terms of the way we feel about the places we live in. So it's not all about zero carbon. There are lots of benefits, other benefits as well. So moving on to the actions that we need now. And this is these actions are in the carbon plan. It's what we've put together as what we think are the priority things. So first of all, 1A and 1B, I've called them here. We feel that people need an independent, trusted advice service. So that if they're thinking about retrofitting their house, it may be if they're thinking about doing some other building work, how do they build in energy efficiency and the zero carbon retrofit things? Where can they get advice from that? And 1B, they also need trusted companies that can do the work. The second action is that when I've flagged some of the problems with retrofit as we've been doing it today, we think we actually need a new way of doing zero carbon retrofit, something that delivers zero carbon retrofit in one go, doing a whole house approach, whole building approach, something that finances the cost of doing it from the energy bill savings that the retrofit delivers, that delivers guaranteed performance and guaranteed long-term savings, so we know it actually works, and that can be delivered quickly at scale by really a new industry, doing things as much as possible in factories and installing components on buildings as quickly as possible with a minimum of disruption. And we think the best place to start is probably social housing, actually, because we can build scale and build a new way of doing it and reduce cost. And this is something that the Dutch government have done, and they developed a way of doing this, which I'll show you a video of at the end in a moment, to give you an idea of what the future could look like. And then the third thing is the main challenge that we've asked you, the Citizens Assembly, to think about. How do you think we can encourage householders and building owners? How do you think we can encourage them or even require them to deliver retrofit to their homes? That's the challenge we've asked you to think about. So I'll just finish up here and talk about how the Dutch government have developed a strategy and a way of doing zero carbon retrofit of housing at scale, using a new approach, an industrialized approach. And I'll just show this, this video here. It might be a bit jerky, but I think you'll get the picture. This is a Dutch company that is retrofitting a house in one day to be guaranteed zero carbon. And here they're just loading up some components onto lorries to go to the house to retrofit it the next day. So a few weeks beforehand, they've 3D laser measured the property, taken millions of data measurings, and they take that back to the factory. Here they've just put some brackets on the wall. It's a good strong wall, and they can hang lightweight panels off it. And those panels will be like a tea cozy, making the property very warm and insulated. So they're taking the components that they've made to site. They've turned up at dawn. The people who live in the house, they could still be living in here, or they might just be going to work and school. They're taking the old windows out. That white box is an energy module with a heat pump in it and ventilation in it as well, that all connects up with the house and the panels. These panels in here are just hanging off those brackets. If the wall wasn't strong enough, they could build new footings to support the panels around the house, craning them in around the back and into the upper story. A quick job to connect plumbing and electrics to the new energy module. The gas has been disconnected, and the only works inside are just creating this new windowsill and reveal system. Creates a nice deep windowsill up against a triple glazed window, which is already installed in the panel in the factory. The roof, all they've done is taken the tiles off beforehand, and this lightweight insulated roof goes on top with the bars already there for the PV. panels to go on to generate electricity, to use in that heat pump. It's still connected to the grid, but it exports to the grid sometimes, imports from the grid at other times. And it's the afternoon now, and these are the final panels arriving to site from the factory on the gable end of the building, and they all just clip together, airtight, and the ventilation system makes sure that the air quality inside the home is always good, and there's no more mold and damp or anything like that. That's the factory made guttering and ridge line going in, just clips together. This is just the afternoon of the same day. Here they're doing something else. They're adding a new room to the house, actually, using a factory made unit, which is capable of becoming a ground floor wet room in the future. This is just a specific example from this project, but they're using industrial off-site approaches to building retrofit means that you can add accommodation to it a lot more easily than you can by building on site. So you come home from work or school in the evening and your house has been transformed. It looks like a new build home, but it is actually an old home. It's guaranteed to be warm and comfortable every day for a guaranteed low bill, and the energy bill savings and the maintenance savings pay for the capital cost of doing that retrofit by that company. And if you think of doing that to every house in the terrace and then the whole neighbourhood, you've also regenerated the look and feel of the home. You've made it look great. So that's how the Dutch are doing it in thousands of homes a year, and that's how we think we ought to do it here in the UK. And but we're not going to get there in one jump. We have started to do this in the UK using this new approach, and Devon was one of the first places in the country to do this. And these two homes are in North Devon, owned by North Devon Homes, part of a project that delivered 16 home retrofits, and there's more to follow in Devon. But it's going to take a long time to get there, so we need to support people to do retrofit now, as well as developing this way of doing it for the future. So that's it.
So